Hello guys, you're welcome back to the channel. This is BRAINX TV, a channel that is dedicated to ensuring that learners understand the basic concepts of mathematics so that we can together say that mathematics is the easiest subject ever to be taught in schools. Please do well to subscribe to the channel, pass comments on the lessons that we are having, and if there's anything you don't understand, please write it up in the comment section and it will be addressed to your utmost understanding. As well, share the link of the videos to your friends so that we can all learn mathematics the easiest way, and we can all say that mathematics is the easiest subject ever to be taught in schools. Today we are considering equivalent fractions. An equivalent fraction is a type of fraction that looks at writing a particular fraction in so many ways. So we will define equivalent fraction as fractions that have the same value but with different representations. Fractions with the same value but with different representations are called equivalent fractions. So let's illustrate it with a diagram. Let's take this to be an orange that is to be shared by two people. So one person gets the shaded portion. So the fraction to the shaded portion is 1/2. Now, the same orange is being shared by the same two people. But over here, the orange is divided into 4 equal parts. And since there are only two people sharing the orange, one person will get the shaded portion. So, the fraction for the shaded portion is 2/4. Another orange is being shared by two people, the same two people, but today they're divided into 6 parts. And one person still gets the shaded portion. So the fraction to the shaded portion is 3/6. Now, the same orange is being shared by the same two people, but today it has been divided into 8 equal parts. One person gets the shaded portion. So let me use the red ink to show the shaded portion. Alright, so you can see that the fraction for the shaded portion is 4/8. Now let's compare these diagrams. You can see that when it was shared by two people, one person got the shaded portion over here as 1/2. When it was shared by divided into 4 equal parts, one person got the shaded portion as 2/4. When it was divided into 6 equal parts, one person got the shaded portion of 3/6. When it was divided into 8 equal parts, one person got the shaded portion of 4/8. If you look at the nature of the diagrams, you can see that always this portion is shaded, and the side that looks like a D is not shaded, so that's for another person. Where the unshaded portion looks like a D, although it's divided into 2 parts here, but still the shaded portion looks like a D. Where here, although it's shaded into 6 equal parts, the shaded portion here has 3 sections and it still looks like the D. Then the last example, the shaded portion still looks like it, although it's divided into 4 equal parts. So that means that in one way they are the same, because the unshaded portion is in the form of a D for all of them, although they have different representations. So we can say that 1/2 is the same as 2 over 4 because they all take the shape of a D, which is the same as 3 over 6, also the same as 4 over 8. I hope you can understand what we are saying. So although they have different divisions or dimensions, still they all take one particular shape, D throughout the diagrams. So in one way, the D shows that they are the same. In another way, the divisions show that they are not the same. So that is the concept of equivalent fractions. So as we said that they are fractions that have the same value, which is, in the diagram we compare it to the D, the same D throughout, but with different representations, different divisions. So you understand what we are saying. So equivalent fractions are fractions that have the same value, but with different representations. Let's look at another scenario where two people are sharing 40 Ghana cedis. So one person will get 20 cedis. That's if it is shared with the 20 cedis notes, two 20 cedis notes. One person gets one 20 cedi notes, the other person gets 120 cedi notes. Now what with the 40 cedis is in 4 10 cedi notes. Then one person will get 2 of them, another person will get 2 of them. If it is in 8 5 cedis notes, one person will get 4 of them, denominations still totaling 20 cedis. Another person gets 4 of the denominations still totaling 20 cedis. So you can see that that is the concept of equivalent fractions. Although with the first one, the person got 1 note, 1 20 cedis note. In the second instance, the person gets 2 of the 10 cedis notes. In the third instance, the person gets 4 5 cedis notes. They all give a total of 20 cedis. So that is the concept of equivalent fractions. So they have the same value, but with different fractional representations. All right, now let's get to how to write equivalent fractions. We have the addition approach and the multiplication approach. We're going to start with the addition approach. Let's take an example like 1 over 2. This is the approach to writing equivalent fractions using addition approach. 1 over 2, the numerator is 1 and the denominator is 2. So with the numerator, you add it to itself. You get 1 plus 1, that gives us 2. And the denominator 2 will add to itself 2 plus 2, and that gives 4. To get the next one, you now add the first number or the first numerator to the second numerator, so you can get the third denominator. So 1 plus 2 will give us 3, and 2 plus 4 will give us 6. Please help you understand what we are doing. Now to get the next one, 1 will be added to 3, so 1 plus 3 will give 4, and the denominator 2 plus 6 will give 8. Then the next one, 1 will be added to 4 to give us 5, and 2 will be added to 8 to give us 10. So hope you understand it. So what do you think will be the next equivalent fraction? Yes, so I know that you've understood. So I know you said the answer to be 6 over 12, because 1 will be added to 5 to give 6, and 2 will be added to 10 to give us 12. What do you think is the next equivalent fraction? Good. I know you said 7 over 14, because 1 plus 6 gives 7, 2 plus 12 gives 14. And equivalent fractions do not end, so you can write up to infinity. That's why we have these 3 dots over here. All right, let's take the next example. Let's take 2 over 3. What is the next equivalent fraction? Yes, I know that you understood it from this side. So I know you said that the answer is 4 over 6, because First of all, you add 2 to itself. So 2 plus 2 gives 4, 3 plus 3 gives 6. Now what's the next equivalent fraction? Good. I know you said 6 over 9. Then the next one, 8 over 12. Good. I know you said 8 over 12. Because I believe you have understood the concept very well. So the next one is, good. I know you said 10 over 15. The next one is, good. You said 12 over 18. That is so good. See, you understand the basic concept of mathematics. And I'm very proud of you. So the next one is, good. I know you said 14 over 21. So let's put our ellipsis over here so that it's continuous till infinity. So this is the main concept of equivalent fractions. So let's try 2 more examples as we bring our lesson to a close. 4 over 5 and 3 over 7. So pause the video and write the solution down. Right, now let's get to work. So we know the answer is 8 over 10, 12 over 15, 16 over 20, 20 over 24, 20 over 25, 24 over 30, and so on. And the last one, I know you get it right. So you get 6 over 14, 9 over 21, 12 over 28, 15 over 35, 18 over 42, and so on. Now at this point, I know you're wondering that, say, what should be the limit to writing equivalent fraction? It will be spelled out clearly to you in the question. So let's take one of it, that write 5 equivalent fractions for 2 over 9. Now, it says write 5 equivalent fractions for 2 over 9. So it has been spelled out to that you're writing 5 equivalent fractions. So here we go. 2 over 9 equals, let us list it together. 4 over 18. Good. The next one, 6 over 27. Good. That's why you're a very good student. The next one, 8 over 36. You've written 3 now. And the next one, 10 over 45. Good. And the last one, 12 over 54. Good. I know you've done it perfectly. That is so correct. So this is the concept of equivalent fractions. Please do well to like the video and pass comments on anything you don't understand, and it will be addressed to your utmost understanding. As well, share the link of the videos to your friends so they also understand the concept of equivalent fractions. Then we can together say that mathematics is the easiest subject ever to be taught in schools. See you in our next videos. Bye.